Second of all is sort of related to the open source fact. The people who started working on coreboot back in '99, that was the Los Alamos National Laboratory in the US. They were building a supercomputer cluster with a couple of thousand machines. And they really didn't want the keyboard error, press F1 to continue message on their 4,000 machine cluster. So they did the only natural thing and they started an open source firmware project. Also, I think another reason why coreboot is really relevant is that we see a number of things coming up now lately, the last few years, in the security research field, where there are issues and risks that I'm going to mention a bit later with the firmware. And because we don't really know what's going on there and we don't have a full insight into this execution stage, there's a lot of stuff that can be going on there, and that's not really so nice. So the BIOS doesn't work really now the way it used to. I mentioned these software interrupts. They really worked as an API. So the operating system and applications would call into the BIOS to do simple I/O, like output characters on the screen or to the serial port, or maybe read from the keyboard or whatever. And this was how the system ran, and it's not really different from an operating system, just that, or not different from today, just that today the operating system has all the drivers and the BIOS isn't really involved at all. So this changed when the first laptop came about. The first PC laptop, it had a lid so you could close it, and when the boss closed the laptop lid, he of course wanted it to shut down automatically. So there came APM. That was the first power management technology used in PCs. When you close the lid, the processor would switch into a new execution mode called system management mode and do a shutdown, clean shutdown of the system, sort of pause everything that's going on in the system and then power off so that you could just close the lid and pack the laptop in your bag. So how many of you guys know about system management mode in here? Okay, maybe 10 out of, say, 80, 90. That's good. It's good. System management mode, as I said, it's a new execution mode introduced in the 386 SL processor. So this is a really old technology, almost 20 years old. When the processor switches into system management mode, it really freezes time. So whatever is happening in the computer is completely stopped and no changes are allowed. All the state is saved. Once in system management mode, the processor can execute some small functions and really do whatever it wants to, because the normal system is completely stopped. So all state is saved and a pre-configured system management mode handler is executed. And there was also an electrical signal added to the processor, so a new pin, a new interrupt pin, which is, of course, what was used for signaling that the lid was closed. So when you close the lid, this pin wiggles on the CPU, and the CPU switches, pauses whatever is running in the operating system, switches into system management mode, which will do hibernation, save state to hard drive or to memory, and power off. It's not only this new interrupt signal, though. System management mode can also be invoked by SMI traps. And these SMI traps, they're really a software filter. So you set up a number of rules where accesses to particular RAM locations, so particular addresses in RAM, or particular I/O ports, I/O addresses, will in fact trigger this system management mode. And using this technology, you can quite easily virtualize hardware. Because, for example, the PCI bus runs really completely off of 2 I/O ports, or, well, 8 I/O ports, 8 I/O addresses. And if you hook these I/O addresses to go into system management mode, an operating system trying to scan the PCI bus could, when it reaches a special point, be moved into system management mode, or the system switches into system management mode, and there's a system management mode handler which replies just as if there was actually a PCI card plugged in. But in fact, it's just a virtual PCI card running in system management mode. AMD Geode, the Geode series, which is what we were using in the set-top box, and also something that's been well supported throughout the history of Linux BIOS and coreboot, because AMD really help us out a lot. The Geode platform, it works like a PC, but it's really a new architecture, and it uses system management mode to virtualize PCI devices, like I just described. Also, any PC that you might have that supports USB keyboards and USB storage in the BIOS will be using system management mode, especially for the keyboard emulation. If you have, if you're able to plug a USB keyboard in and still type stuff on that to your bootloader, then you can know that your USB BIOS, your USB BIOS is running some system management mode handler. The PS2 keyboard is also using I/O ports. So when the bootloader tries to talk to the PS2 keyboard on these I/O ports, in fact, it triggers system management mode, which will communicate over USB instead, and then return a result just as if there was really a PS2 keyboard. APM was the start, the first try at some kind of power management, power awareness in PCs. After that came ACPI. So ACPI is the Advanced Configuration and Power Interface Specification, conjured up by friends at Hewlett-Packard, Intel, Microsoft, Phoenix, the major BIOS vendor, and Toshiba. The revision 3 document, which I've had access to, or which I've found, is from 2006 and some 600 pages. Among other things, for the configuration part is pretty simple. It specifies tables of what hardware is in the system, how much memory do you have, etc., etc. Nothing really spectacular. For the power part, it specifies a virtual machine which has its own bytecode. And this virtual machine runs in your BIOS. So outside the security controls of your operating system. Is it really outside the operating system? Yeah, at first they implemented it that way, but it turned out to be way too slow. The performance hit was, I've heard the number 5% performance lost because the ACPI virtual machine was implemented all in the BIOS. I'm sorry, I just remembered I forgot to plug my laptop in. There we go. This virtual machine, it moved into the operating system because of this performance hit. It was just unbearable to have 5% gone. And Linux started doing this in 2001. I've seen the number 90,000 lines of code in the Linux kernel to implement the ACPI virtual machine.